Maybe, I don't know, I haven't done this in a while, guys, this particular question. So we're gonna see if it's cumbersome, we'll just use a calculator. But if it's not so cumbersome, let's see if we can tackle it. All right, so they want this area. I have two regions. You guys see that? One way to find this area is to do this in two integrals. You guys ready? So this region here in red, I'm gonna color code, so if you have colored pencils, this is a good place. See if you can do the UT on-ramps, not the high school stuff, but like the college exercise assessment, homeworks first. And then once that's out of the way, I'll like clear, unless it's already cleared, but I don't remember. You know what I mean? Does that make sense? Yeah, I'll open them up as soon as, yeah. Okay, here we go. You guys ready? I want that region in red, or I guess region A. I'm gonna integrate. It looks like it's just, that region in red is just the x-axis to that curve, and I'm only going, it looks like I'm going to 2. 0 to 2, and that curve, they told me that curve is square root of x. Put a dx. Plus, am I still okay? Now I want this region here in blue, so I'm going to color code it with blue. That region in blue, I'm going to go integral from 2 to x value 4, and then what curve is on top? Square root of x minus what curve is on bottom? X minus 2. There is my setup. If you want to put a giant parenthesis like that, that's fine. That's your setup. Now is, can you do the algebra? Now I'm just gonna do a neutral color like black here. So here we go. You guys ready? I'm just rewriting it. So I'm making it easier for myself. X to the half dx plus integral 2 to 4, and I'm just rewriting it. X to the half minus x plus 2. All right, let's see if we can do this. Sorry guys. It does that from time to time. What's antiderivative of x to the half? Yeah, I like to, yeah, perfect. X to the 3 halves divided by 3 halves, so 2/3. And then since I have two different expressions, I'm going to put this in a bracket like so. Usually I would only use a line, but I have two integrals and I want to separate both of them. Does that make sense? And I'm going to put a plus symbol. That plus is this one. And then here I go again. I'm going to put these three terms in a bracket. What's the antiderivative of x to the half? It's the same thing, right? 2/3 x to the 3 halves. Yeah, it looks like it could be cumbersome, but let's sweat for a little bit. Antiderivative of x is x squared over 2. Do you want to keep the same theme and just put a half, or put it as over 2? Same theme as what I have in the first term there. And then plus antiderivative of 2, 2x. I close my bracket, and those three terms, I'm going to be evaluating it from what to what? Yeah, always do 2 to 4. There it is. And of course, when you evaluate it, do upper minus lower, but you say 2 to 4. Okay. How do we feel? That's probably a point. That's probably a solid point. And then the other, by here, I'm taking a guess. This will probably be worth like a 3-point question, a 3-point tier. And by here, you probably have 2 out of the 3. You got correct limits, you got correct integration, you did the correct antiderivative, and then 1 point for the answer. I'm just, it just depends. It depends. Every rubric is different. All right, can we do this one really quick? Let's see. Yes, we can. So if I plug in a 2 there, so this is what it means. I'm going to write the 2/3. Well, I guess we'll just write it for now all over. 2/3, 2 to the 3 halves, plus, you don't have to worry about the 0, right? And then I'm going to put a bracket, giant parenthesis for the 4. So 2/3 times 4 to the 3 halves minus half of 4 squared plus 2 times 4. Close that giant parenthesis, minus, open another one, and now I'm going to plug in a what? A 2. 2/3, 2 to the 3 halves, minus 1/2, 2 squared, plus 2 times 2. Close that, and I put a bracket, so bracket. If you are paranoid, and this is an AP question, free response, this would be correct. A professor might grump, he might be like, oh, but it's correct. They got to give you the point because we've been instructed, they don't have to simplify. We're going to sweat. Let's see if we can figure this out. So here's what I see. I see, and I'm just changing colors here just so I can see what's up. I see when I distribute there that this expression will be negative. But I also see this expression right here, that one's a positive. Do you guys see that? So can I just, do I have to really calculate what that number is right there? You can just take it out like that. Do you guys see what we did? All right, let's see. Do we see anything else that can be taken out? Looks like that's it. I don't see anything else. All right, let's see. Let's see what we have. Oh, wait. 1/2 4 squared. 4 squared is 16. Half of 16 is 8. I don't see another 8. Oh, okay. Yeah, I got you. 4 squared 16. Half of 16 is 8, and then 2 times 4 is 8. So that's, and they're opposite polarities. So these cancel out. Good job. Do we see anything else? 2 squared 4. Okay, that's it. So let's see. How do we do this? How do we do this? Here's how we do it, guys. That 4 to the 3/2. Just do law of exponents. So that 2 in the bottom means square root. The square root of 4 is 2. And 2 to the 3rd power is 8. So I have 2/3 times 8. I'm just going slow, guys, in case you're wondering. And then I have minus, let's see. 2 squared is 4, and half of 4 is 2. And then again, you're going to distribute that. And then 2 times 2 is 4, so minus 4. Are we still okay? No? Uh-oh. Let me see. Yeah, you're right. Plus 2. And okay, now we're right. Yeah, I'm distributing the negative. There's a negative there, so we're good. Have I made any mistakes so far other than that? Okay, we're good now. So this I can do really quick. 2 minus 4, that's just negative 2, right? And then 8 times 2 is 16, so 16 over 3. So I have 16 over 3 minus 2. 3 goes into 16, 8, 12. Nope, it doesn't. Are we still okay? You can actually leave it like that, and they would still also be correct. I'm going to turn that 2 into 6 over 3. 6 divided by 3 is 2, right? So 16 over 3 minus 6 over 3. And finally, here's my answer. 10 over 3. And I'm sure if we do this with a calculator, that's what we'll get. How do we feel? Okay. All right. We did a good job there, guys. Good job. We're going to do the same problem. This is by design on purpose. We're going to do the same problem, but different. We're going to do geometry. Do you see a shape somewhere in there? Not necessarily in the shaded region.
That's not a good triangle.
Oh, yeah, no, yeah, it is a good triangle.
It's part, no, from 2 to 4. The part that's not shaped.
Good job. Look at this, guys. This in green. Do you guys see this in green? This in green is a triangle. If you see that, does everyone see that green triangle? If you see that, then you can just say, check this out, you can do this. I'm going to find the area under this one curve all the way, and then I'm going to subtract that green triangle. And I bet you we'll get the same answer. Let's see. You guys ready? So I'm going to color code it. You can see what I shaded in red. It's everything under that one specific curve. So I'm going to go integral from 0 all the way to 4. So now I'm integrating all the way to 4. Of what curve? Square root of x dx. And I'm going to subtract. What am I going to subtract? The area of the, I'm just going to put area of green triangle.
Would that be acceptable on the AP exam? Like it won't be like, sorry, you should have done it this way.
If I'm writing it like the way I'm writing it right here, yes. If they were to ask you, what's the area of that region? Like, oh yeah, this kid used geometry. Usually they do it on purpose.
Would you be able to write area of green triangle?
Yeah, because I'm choosing a neutral color now. So this is going to be the same thing that we've always had. What was it? 2/3 x to the 3/2? 2/3 x to the 3/2. I said 3/2, but I wrote 3/4. 0 to 4 minus, giant parenthesis, let's see, the difference between 1/2 base, the difference between 2 and 4 is 2, and then the height is 2. It looks like it. Yeah, 4, 2. All right, so let's see. If I evaluate this, let's see, the square root of 4, we just have to worry about the 4. 2/3, 4 to the 3/2 minus 2 times 6 is 4 minus 2. And yeah, it's going to be the same thing. The square root of 4 is 2. 2 to the 3rd power is 8. 8 times 2 is 16. So look, 16 over 3 minus that 2 is 6 over 3. And OMG, did we get the same result? We got the same result. Yeah. Whatever you see is better. Whatever you see is better. Whatever you see that you think is easier for you, do that. Because that's what's best for you. Now check it out. Don't go to the next page without looking at this. Notice on this, what they're trying to do, notice those rectangles are not perpendicular to the x-axis. They're perpendicular to the y-axis. So these cross sections or these rectangles, those are all dy's. The thickness. Do you guys see that? You guys know what I'm talking about? When I go when I go I'm talking about like quote unquote my rectangle cross section. I'm slicing it. Bam, 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 bam. And I have all these, and this delta, that change in whatever, that's not a change in x, that's a change in y. So all these slices are dy's. Do you guys see that? So because all these slices are dy's, we're not going to integrate with respect to x. We're going to integrate with respect to y. So that's what we're going to do next, guys. So we're doing the same problem. I wish I should have probably drew it in there, right? Darn it. Okay, same problem. Should we do a rough sketch? Did you get a visual? Here's that same problem, guys. Oh, man, my sketch sucks. Okay, it doesn't go through the x-axis. That's why it sucks. There we go. That's better. I think I got it all. Yep, got it all. All right, my drawing is not as cool as their drawing, but that's fine. If we do a cross section, so here's me doing one cross section. We're not doing volumes, we're just pretend there's a rectangle right here, right? Like that. So here's my one cross section. Boom. That is not a dx, that is a dy. So Chavez, how do I know what curve is on top? Well, this is number line, this x-axis, further right would be considered on top because those are the positive numbers. Does that make sense? Yeah. So this line here, the linear line, is considered on top. And then this line here, the square root function, is considered to be on bottom. Say it. A cross section. Just so I can figure out, like, is it a dx, is it a dy? So in case you don't understand what I'm talking about, guys, when you see a green line doing, when you see me doing this, I'm trying to figure out my cross section. That's a dx, right? And you can have a whole bunch until all these until you get to here. Then you got a different type of dx with two curves. But if I do this, it doesn't matter where I cut it. So I guess that's what I got to be more specific. It doesn't matter where I cut it. It's always affected by those two lines. So I only have one integral as opposed to two. Does that make sense? If you do a dx, you're going to have two integrals. It's what we just did right here. If you do a dx, those are dx's. Here's the dx, bam, and then here's a different type of, upper minus lower. Does that make sense? But if I do a dy, it's only one equation. Do we see that, guys? Okay, so here we go. These are dy's, so that means I need these equations in terms of y. So x equals something. So let's figure out what that is, guys. So that equation, in terms of x equals something, move the 2 to the other side. X equals y plus 2. Do you see how we did it? All right, let's do this one. I need it in terms of x equals something with y, right? So how do I get x by itself? I'm going to have to square it. So x equals y squared. Are we still okay? Now remember, we're doing dy's, so I don't look at the x-axis. All these are dy's. I'm going from 0 all the way to up here. And that number is 2. Is everyone okay with that? All right, so tell me, what's going to be my new integral? I'm going to put integral 0 to 2. Which one's on top? Y plus 2. Don't put a square on it. You're doing volume. Just like that, right? Upper minus lower. Minus, which one's on bottom? Y squared. And what did I put on the outside? A dy. These are all y's. Are we still okay, guys? Let's see if this is easier. Should we rewrite it? Integral 0 to 2. Let's put the y squared in the very beginning. So negative y squared plus y plus 2 dy. Here we go. Antiderivative of negative y squared. Perfect. Plus antiderivative of y. And antiderivative of 2. And all this is from what to what? Do I have to worry about the 0? Nope. Unless you had an exponential function, but nope. Yes. Oh, that's the line that's on top. If I were to rotate this 90 degrees, the y plus 2 is on top. You always do upper minus lower, right? That's what we did for, that's what we did, yeah. Upper minus lower, upper minus lower.
Yeah, if you said that the y-axis was down.
Yeah.
Then.
Oh,
Yeah, okay. Like the y-axis is down.
We still okay? Here we go. Equals, let's plug in the 2. Negative 2 to the third power over 3 plus 2 squared over 2 plus 2 times 2. Let's see if all that is what we think it is. Negative 2 to the third power, that's a negative 8. Negative 8, 3. 2 squared is 4, divided by 2 is 2. And 2 times 2 is 4. So now I have negative 8 over 3 plus 6. Multiply that 6 by 3. Negative 8 over 3 plus 6, 12, 18. Oh, look at that. Negative 8 plus 18 is... How are we feeling? Do we feel okay? All right, we're done. Now we're just practicing. Yeah, the rest are just practice problems. Okay, you're gonna need your calculator, guys.
well, I'm sure you look at now. Like, the offers-
Okay. Here we go. This is just like your UH quiz. Find the area of the region enclosed by the graph, y equals x cubed, and x equals y squared minus 2. So they want this region. Here's what you're going to type in. Well, y equals x cubed, that's just easy. So on y1, go x cubed. Now this one, if you want to type it into your calculators, also in the Nspire, because the Nspire doesn't have x equals, you're going to have to solve for y really quick, just so you can know what to plug in. So it's really simple, guys. Move the 2 to the other side. So you're going to have y squared equals x plus 2. And then how do I get rid of that square there? Now remember, this is plus minus. So on y2, I'm going to type the positive 1, x plus 2. And on y3, I'm going to type the x plus 2. And let me go ahead and color code this. So that negative part there is this. Trying to color code it. Cool or not cool? Okay, type that into your calculator, guys. I'll do the same. Y1. Oh, let me reset mine. X cubed. Square root. I already forgot. Short-term memory. Was it x plus 2? X plus 2. And negative x plus 2. Okay, I want it to look like that graph, so I'm going to steal this dimensions. You see the dimensions down here? That's an x value, negative 3 by 3, and that's a y value, negative 3 by 3. So I'm going to do that. Window, negative 3, 3, negative 3, 3. And there it is. It looks just like theirs. You're going to want to save all of these intersections. What do they call it? A, B, C, D? A, B, C, D. Okay, yeah, they just went down the alphabet. So let's find, I don't know if you guys can see this cursor. Let's find that intersection. It's a black line with the blue line. And we're going to call the X an A and the Y a B. And I'll show you how to do that. So how do I find that intersection? You guys tell me. Second cal. Now you have more than 2 equations. So number 5, intersect. And it says the blue curve, yes. The red curve, I don't want the red curve. I want the black curve. So there's my second curve. Push enter. And then I'll show you. I went second. Yeah. And now it says guess. I don't want to guess. Well, there's only one intersection anyway, so just push enter. And there it is. Oh, it's a perfect negative 1, negative 1. Do we need to save that to anything? No, because it's perfect. So don't worry about that one. But the one over here, where the blue and the red is, those might not be perfect. Or it might. We'll see. Do it again, guys. Second calculate. Number 5. First curve. I can't tell which one that is. Oh, there we go. Red, yes. Second curve. Nope, not that one. The blue one. There it is. Yes. Guess. Nah. Okay, that one you're going to want to save. And I'm going to be consistent with the notes, I'm going to use their letters, C and D. Do you guys see that? So, to be consistent with the notes, so check it out. Quick, for those of you that are in computer science, here's a computer science thing, because all this is all related. You see that X value there, and you see that Y value there? The calculator has it's called registers, and that value is being stored right now under that register, or that variable. So if I go to the home screen, second quit, and I type the X, and I push enter, there it is. But Chavez, how do you get the Y? Well, there's a Y down here. You see it in blue? Push alpha, alpha, and then push Y, and then push enter, and OMG, it's that Y value. Do you see how we did it? So let's go ahead and store the X as, I should have done it, sorry. X, store it as what? C, alpha C, enter. You don't want to use X and Y, guys. You want to use different letters. And alpha Y, store it as what? D, alpha D. So there it is. My X is a C, my Y is a D. And it works the same with the TI Nspire. Are we cool? Yeah, which one? Both? Yeah, okay, so you just go X, push the stow button, and go alpha C, and then push enter, and it should be 1.21. And then to show the Y, you got to push alpha first, alpha Y, push the stow button, and then go alpha D, enter. Where's the what? The C is where the program button is at, under the stat. Okay, are we ready, guys? Here we go. So let's look at this. I am going to, so check it out, guys. Let me erase all this so you guys can see. And I like to draw, I'm going to do a dx first. If I do my dx right here, it depends specifically on the y equals square root of x and the y equals negative square root of x. Do you guys see that? Or no? So Yes. So I'm gonna do two integrals. I'm about to find my area. I want to find this area right here. I do a cross section, I do a dx, and it depends only on this curve. It looks like this is upper, the positive square root, and this is lower, the negative square root. What's up? Ask. All I'm doing is this. I'm doing like this part right here, like that. Upper minus lower.
Yeah, does that make sense to me? But why are you doing just that section and not?
Well, I'm only doing it up to here because after I pass the point AB, then it depends on two different curves. I'm finding the area, you know what I mean? All right, so here we go. Integrate from what to what? -1, negative. This looks like it's -2. -2 all the way until I hit A, and we saw that A was -1. And then the upper curve, that's the positive square root of x plus 2. And I know you guys are really smart, and you can probably just say, Chop, just put a 2 in front of that because it's twice. You're right. But I want to show you all the details. Upper minus lower. What's the lower curve? Negative square root of x plus 2. You can see that the negatives are going to cancel each other out, and it's going to be 2 of them. But I'm not going to worry about that because I'm just going to type it into my calculator because y1, y2, y3. I got them all in there. What's up? How did we get the what?
How do we get -2 as a low?
It's not a low. Yeah, that's my x value up here.
Oh.
Sorry, miss. I'll erase it. There it is. That's it. You're done for that part. That is only covering this here in red. So there's my color coding. Now I want to get this here in blue. So I'm going to go plus integral from what to what? -1. Well, let me get this out of the way here. There we go. -1 all the way. What was my to what value? C. That's stored in the calculator. Now what is on top now? Square root of x plus 2. And then what curve is in the bottom? X cubed. Do you have to do anything by hand? Like, do I have to take the antiderivative by hand? No, everything's done in the calculator, guys. So don't even bother doing anything by hand. This one I think was saved in Y2. This one I think was saved in Y3. And this one I think was saved in Y1. So let me put all of them here. That was Y2. So there it is. So that's how your calculator is going to look, guys. So let's do it. So here's my calculator. I go to my home screen. I'm going to clear all this. I'm going to go math 9. What was it again? I already forgot. -2 to -1. And then I put in here Y2 minus Y3. Sorry, guys. Alpha trace Y2 minus alpha trace Y3. Yeah, it'll probably work if you put 2 times Y2, but I'm trying to be correct, like, you know, just to make the concept here. X, and I'm going to go ahead and do one line plus math number 9, and then -1 all the way to C. So there's my C. It's already stored in my calculator. And was it Y2? Alpha trace Y2 minus Y1, right? Alpha trace Y1. And put an X, and let's see what we get. 4.2149. 4.2149. Okay. That was tough. Was that tough? I think that was tough. There was a lot of moving parts. So here's what we're going to ask ourselves. Yes. Here's what we're going to ask ourselves. All those moving parts, could we have done this simpler? Yes. If we would have integrated by what? Y. No, yeah, you're right. Why? Because, yeah, I know it's funny, play on words, why? Because check it out. It doesn't matter where you are at. If we just do integrate with respect to y, it's just one integral. Do you guys see that? It's just one integral, upper minus lower. So yeah, we're going to do a hack. So let's see. We're going to integrate. Now I need my y value, so I need that b. That b value is a -1. And I'm going to integrate all the way to the d here, the y value, right? So I'm going to put little d here. Of course, it's d in our calculator, but whatever. Are we still okay? Okay. So now, Chavez, what about this curve? Well, we're integrating with respect to y. So now that's now no longer an x cubed. You're going to say, let's see. On the side, I'm going to write y equals x cubed. Yes. Yeah, we're integrating with respect to y. So we need the y values. We need the b, and we need the d. So this is a -1 down here. And up here, it's whatever this value is, which was the d value, the y value. Okay. Are we still okay, guys? Okay, we need to turn all these equations in terms of y. So how do I get that cube out of there? Yeah, either cube root. No, you're good, miss. You're good.
Square cube. I tried to say square root, but like cube.
Cube root. Yeah, cube root. It's well, the radical is called root, and then you just say the number, right? 7th root, 9th root, whatever. Cube root. You can also say, if you don't like that, you can say y to the 1/3. It doesn't matter as long as you're consistent. Are we okay? All right. And then the other ones, we don't have to worry because look, we already got it. Y squared minus 2. So here's equation number 1. Equation number 2, x equals y squared minus 2. Are we still okay? All right. Here we go. I'm going to zoom out, and don't worry, I'll zoom in a little bit. From -1 to 2, and then what curve's on top? The x cubed, which is now going to be called, yeah, I'm going to say cube root of y. Y to the 1/3, same thing. Minus, and then this quadratic looking thing, which is y squared minus 2 dy. No, I'm not going to do it by hand. I'm just going to type it into the calculator. So I don't have these saved anymore. I'm just going to type it in. I'm going to use the letter x. That's why you don't want to put the letter x as the limit. Here we go. Math, and I bet you it's going to be the same. Number 9, -1 all the way to alpha d. And then what did we say? We said cube root of y, right? So here we go. You can actually use any letter because you can see, but I just like to use the word x because it's already there and it's fast. You know what I mean? So I'm going to say cube root of x. So in case you're looking for the cube root, guys, it's push math number 4. You don't have to. You can raise it to the exponent 1/3. Get out of there. Minus, and what was my equation over here? Y squared minus 2. I'm going to type x squared minus 2 in there. X squared minus 2. Close it. With respect to x. Here comes the moment of truth. Enter. Look at that. Obviously, there's something funny going on with their calculations, but with respect to the first 3 digits, that's why AP exam does 3 digits all the time. With respect to the first 3 digits, are they the same?
Yes.
Yes. There's something funny going on, obviously, but that's on the algorithm. That's not on the the question itself. That's on the way the calculator executes code. How do you feel? Perfect. It works. I'm just going to put 4.214 truncated. How do you guys feel? We feel good? You think we can do one more together and then call it a day? Or maybe 2 more? All right, so I think we're good on this one, guys. I'm going to let you guys have practice up with example 5 on Delta Math. So let's just skip that one because that's pretty basic. You guys already know. Let's go all the way to the last one. So here it is. Here's the last one, and then we'll call it a day. Here's what we want. Give me an integral with respect to x. Give me an integral with respect to y. That's it. That's what they want. Let the shaded region be enclosed by this function, and the horizontal line y equals 0 on the y-axis. Write an integral in terms of x, and an integral in terms of y. So let's do it. In terms of x, here's my d-axis. In terms of x, I'm integrating from what to what?
0 to 4.
0 to 4. And it looks like it's this. Remember, this line up here is on top. That's y equals 0. So I'm going to write 0 minus, so you guys can see, and then this curve is next, right? Isn't that the square root curve? Square root of x minus 2, close, dx. There's my integral. Yes, you don't have to type the number 0. You could just distribute the negative. Cool? Okay. Now let's do it in terms of y. So now I'm using blue here. So here's my dy's. A dy, a dy, a dy. So integral. What's my lower limit? -2. What's my upper limit? Perfect. No one got tricked. Which curve is on top? Yeah, so maybe we should have figured out what that is in terms of y, right? Y equals square root of x minus 2. Move the 2. Square root of x equals y plus 2. And then I'm going to what? X equals y plus 2 squared. So type that in. Y plus 2 squared minus, and in case you're wondering, this line here is x equals 0, so minus 0. You don't really need it. dy. And those answers should be the same if someone wants to test it out, but they should give you the same thing. How do you feel?
Pretty good.
All right, guys, so now you just have practice on delta. So practice on delta with both of those scenarios. So now you are a more lethal weapon in calculus.
Thanks, Chuck.
I thought that was funny, but no one laughed. Okay. All right, we're done.